بسم الله الرحمن الرحيم. Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are going to continue with chapter 6, architectural design. We are going to cover in this lecture 3, two different patterns. So far we did the model view controller and the layered design, which it is abstract machine design or architecture. Today we are going to cover another two, which it is the repository structure and the client server architecture or structure model. Well, as we said, the topics we covered so far in the whole chapter, we talk about the architecture design decision, the architecture views, and then we went through the patterns. We cover in the lecture before the model view controller, which we divide the system into three different views or different parts. One of them the model, which it is cover the database and some of the logic. The view is the interface, and the controller is the one is between the view and the model. It takes something from the view, manipulate the model, and bring it back to the view. The layered architecture, abstract machine. We divide the system to a layer after layer after layer. The most precious layer, the one which it's probably it has a secure or a safety or whatever, we put it in the inner layer and we divide it in layer. And we said probably this is a good when we use the incremental process model. We could really use each increment represented as one layer. In this lecture we are going to cover repository architecture and the client server architecture. In the next lecture we finish the chapter 6 by having the fifth layer, which it is the pipe and filter, and the final thing is the application architecture. Well, the repository architecture, it is one of the most popular patterns to create an enterprise application, a whole application. And it will restrict us to work directly with the data and the application, and it creates a new layer of database operation. What's that mean? This means we put all the databases are in a repository and the application is around it. And this is, I think, it is the same as the data-oriented approach. Data-oriented approach, we put all data in one database or in one repository, and the application programs around this dealing with these data. So there is no connection between this application except through the database. A repository architecture is a system that will allow several interfacing components to share the same data. Each component interfaces the same dataset that is utilized system-wide. Data manipulation taking place in one component will reflect an identical representation of a data in another component. This means the component, the program, it go and deal with the database in the repository, do any update to it, all the update, the delete, whatever it is, it will be reflected in the other application. This means we update or we do any change to the database through one component, and the result will be clear and will appear in the other component. Components can be interchanged and are independent of other system component. So each component are independent. So the relation between them is through the database. A good example of repository architecture would be a database management system. Such a system would provide both a console and a graphical user interface to update both the structure and data set of any particular database. Well, if you look at any system, it it will be divided to a subsystem and modules. These modules or subsystem, they cannot run by themselves. They are not standalone. They always interact with each other. With this interaction, they must change and exchange data between them. The system update a database. The other system will take that update in his component and do something to it. So subsystem must exchange data. This may be done in two different ways. Shared data is held in a central database or repository and may be accessed by all subsystems, which it is, we're talking about the whole enterprise. The whole enterprise subsystem, like, university system. We have a financial system, we have registration system, we have library system, we have purchasing system. Sometimes there is a relation between these. The relation here and the data here, it must be exchanged between them. So the repository suggests that we put the database in a repository and all these subsystems deals with each other through that repository. The other approach, each subsystem maintains its own database and passes data explicitly to other subsystems. We go to the same approach, but now it is in the subsystem itself. And the subsystem itself, we could have a database there. The component of that subsystem, they always deal with that database as a repository. And then the result of all these, it will be passes to another subsystem. When a large amount of data are to be shared, this means when we're going to use this repository, if there is a lot of common data used by some of these subsystems, instead of having a redundant data in this subsystem and that subsystem and that subsystem, we put it at one place in that repository, and then all the systems there, subsystem, they deal with each other, they interact with each other through that database. Repository model of sharing is the most commonly used. It is an efficient data sharing mechanism. I think it's become really clear, what's repository. The idea about repository pattern is the database in one repository, in one database, and all the application deal with that database around it, and the interaction between those subsystem or module, whatever, it comes through the database itself. So in this case, if we go to the description of that repository, all data in a system is managed in a central repository that is accessible to all system components. Components do not interact directly, only through that repository. Example 6.9, an example of integrated development environment where the component use a repository of a system design information. Each software tool generates information which is then available for use by other one. We'll see the example in a few minutes. When used, you should use this pattern, as we said earlier, when you have a system in which a large volume of information are generated that has to be stored for a long time. You may also use it in a data-driven system when the inclusion of a data in the repository trigger an action or a tool. What's the advantage? The advantage here, since all the data are really in one repository, so the application can be independent. The component or the program around it, they are independent. They do not need to know of the existence of other component. They just go and they deal with the database, and the other component will go to the database and take whatever the update was. Changes made by one component can be propagated to all components. It will impact and it will affect all components and that system. all data can be managed consistently. Since we have one database in one repository, so the backups, the reorganization of the data, all the activity and the database done and managed consistently by the DBA. Why? Because they are in one place and they are in one database or databases. Disadvantage here, when you think about, if you have all the databases in one repository, this means any defect, any problem occurs in one database, it will impact the others. This means that the repository, it's in a single point of failure. So any failure to any database, it will pull the whole system down. So problems in the repository affect the whole system. Any problem in one database, it will impact and affect the whole system. Maybe inefficiencies in organizing all communication through the repository. Distributing the repository across several computers may be difficult. Why? Because they are in one repository database. Well, let's look at this example as an repository architecture. It is an example for integrated development environment. What's integrated development environment? Integrated development environment, IDE, is a software application that provides comprehensive facilities to computer programmers for software development. An IDE normally consists of some of these program or subsystem like source code, editor, build automation tools, and debuggers. In this example here, we see the repository down there, the project repository, and all these programs around it, all these applications around it, like the design translator, design analyzer, report generator, Python editor, Java editor, code generator, UML editor, etc. So all the interfaces between these, like between the UML editor or the code generator or any of other two of these, it will come through the repository. This means one application, it will update the repository, then the other application from there go to the repository and take that update from that program, so it take it from the database, and there is no interaction between the application around the repository. Well, this example is for a language processing system, which it is a compiler. A compiler is a program that converts high-level language, the source code, the code we write it in C, C++, whatever, and it will convert it to assembly language or to machine language. Of course, in order to convert this one, in order to read the source code and create the object code or the machine code, I think they need some component. The component is like lexical analyzer, which is read the source code, divide that, token, take this token, and then compare it to the symbol table to see if that it is a keyword or not, whatever, to find out if there is any syntax error or any semantics error, and then at the end it comes with the object code we need. In any way, what really we care about here is the repository-based model, which it has the abstract machine syntax tree, grammar definition, output definition, and symbol table. The application around that repository are lexical analyzer, syntax, semantics, optimizer, code generator, editor, etc. Well, the fourth pattern architecture we have, it is the client server. Client server architecture is a computing model in which the server, which is the host, deliver and manage most of the resources and services to be consumed by the client, to be used by that client. This type of architecture has one or more client computers connected to a central server over a network or internet connection. Client-server architecture is a system that provides distinct services to multiple clients by logically dividing the services by the service provider. Each service may be hosted on another server, although the services can be co-located all on one server. Several clients may be run concurrent instance of any given service simultaneously. One server can be replaced or undergo maintenance without affecting the entire system. Here we talk about, some of the advantage and disadvantage of it. The independent of the server, dependent of the service. A great advantage of a client-server architecture is a distributed architecture providing the possibility of integrating geologically separated components all into one system. This means we could really integrate a lot of components as they are far away from each other, which it is geologically separated components. All of them, we put them in one system. A good example of client-server architecture is a library system that may provide multiple services to multiple students, such as article database, a book finder, and order placer. Well, this type, which it is the client-server architecture, this type of architecture has one or more client computer connected to a central server. That's what really we said about, connected all these, in the internet connection. This system shares computing resources. This means the resource, it could be really shared by all these components of it. Client-server architecture is also known as a networking computing model, or a client and server network, because all of the requests and services are delivered over the network. Well, distributed system model would show how data and processing is distributed across range of components, which can be implemented on a single computer, or a set of stand-alone server, which provide specific services such as printing, data management, whatever. Each server provide a service, and all of them sitting in the side and the server side, and the client from the other side, and the data and the internet in the middle. So they deal with each other through the internet, the network. Set of clients call all these services, and network which allow client to. So the part of it are set of standalone servers, set of clients, and network or internet in between. Well, let's see what's the client-server pattern, description of it, example, when used, whatever. Description, as we said, in a client-server architecture, the functionality of the system is organized into services. There are services and servers, and there is a client with each service delivered from a separate server. So each service from a server. And then clients are uses for these services, and access server to make use them, whatever. And then again a network internet. Example, it's in figure 611, the one is coming after the slide. It's a film and video DVD library organized as a client-server system. When used when data is shared. When data in a shared database has to be accessed from range of location. This is the important thing itself. It is from a different location. So really you could put a server in each location, which give a service, and then you connect it to the net. Because server can be replicated, may also be used when the load on a system is variable. What's the advantage? The advantage of this one, probably, well, it depends. You could say really many of them, whatever. Well, improve data sharing, integration of a service, probably shared resources among us different platforms. You share resources for many different platforms, as we said, each server in a different geological place or whatever. Then easy maintenance, because you work on each service by itself if you want to maintain it. You don't put the whole thing together. And then, well, you could say really increase security, because if you apply security for each server things in. The principal advantage of this model is that server can be distributed across network, which it is many different platforms, as we said. General functionality, like printing service, can be available to all clients and does not need to be implemented by all services. So we have it in one service only. But what if that service goes down? Well, this is one of the advantages we are going to talk about now. The disadvantage, if all clients simultaneously request the data from a server. Assume, there is a lot of people. It's like, when we register in our registration system, when all students go to the server and try to register at once, I think it will get overloaded. If the server fails for any reason, this means the request, it will not be available. And the cost. Well, another advantage is the cost of setting and maintaining a client-server model is quite high if you compare it with other patterns. Each service in a single point of failure, so susceptible to denial of service attacks or server failure. Performance may be unpredictable because it depends on the network as well as the system. Well, it depends again on the network, which is really a disadvantage, and as we said, probably it will be overloaded, if the network it's not enough to handle all the user or the clients. Maybe management problem if a server are owned by a different organization. Again, if every server owned by different company or different organization with different rules, whatever, probably it is tough to manage such pattern. Well, finally, in this lecture, we have an example of client-server architecture for a film library. You talk about, for a library, you have a lot of clients 1, client 2, client 3, and then down there you see the services, like, catalog server, video server, picture server, and web server. And each of them, they come up with one, probably, or more services. And there is the thing in the middle, it is the internet or network. There's a lot of examples, as you know, all the application in the internet, probably most of them like a client-server architecture, because we have a client on the side, we have servers and services on the other side, and the net in between. So by this, we finish this lecture, and what we still have the fifth pattern in the next lecture, and the architecture examples, and we will cover them in next lecture. Bye.